Hey everybody, it's Mr. Carr again. Today we're going to be looking at 8.3 day 2. We're going to continue with our area. In this case, we're going to be doing trapezoids, rhombuses, and what's called kites. Okay, so the first one is an area of a trapezoid. First of all, let me just help you identify what is a trapezoid. It is showing two bases, B1 and B2. Basically, a trapezoid has to have exactly one pair of parallel sides. Okay, so whereas a parallelogram has two pairs of parallel sides, a trapezoid only has one pair. And you can see that's the B1 and B2 right here. So those are my parallel sides there. We have a height of the trapezoid that is perpendicular to actually both bases here. So that height is going to be perpendicular in between like that. So area is going to be 1/2 base 1 plus base 2 times the height. And height is the distance between the two bases. Okay. So when we look at these, we're just looking for mainly just plugging into the formula as long as we have all the information we need. So we start with the example 1 here. Base 1 is 16, base 2 is 8, then height is 8 root 2. Okay, so I'm just going to plug all those into the formula. So I'm going to take area is equal to 1/2 of 8 plus 16 times 8 root 2. So we're not usually going to do like exact values here. I'm just going to plug it all in my calculator at once. So we got 1/2 times 8 plus 16 times 8 radical 2. Okay, and that comes out to 135.76. And because this is area, that's going to be square feet. Okay, for the next one, we do have the height here. That's h is 4. We have base 1 is 7. Now base 2 is down here. We don't quite have that information, but here's what I can do. Remember, with the height, I can kind of draw it anywhere I want, like this. So that would be a 4. That would now make this a right triangle. And with that right triangle, I'm going to call this x right here. Then I can do Pythagorean theorem. So I would say that x squared plus 4 squared is equal to 5 squared. Thankfully, this is also Pythagorean triple. I already often know that because of 3, 4, 5, x is going to come out as a 3 here. Now, because of this, because of the 7, this is going to be 7, and now x is 3. So base 2, if I do 7 plus 3, comes out to 10. So I did a little bit extra, but that was just to find out this missing piece of information. So just keep in mind that sometimes I give you a little bit less information than you are going to need, but you can always find enough there. So that means my area is now 1/2 of 7 plus 10 times my height of 4. Okay, so that is going to be 17 to, that'll be 34, and those will be square feet. I believe 0.5 times 17 times 4. Yep, 34. Okay. The last two formulas we're going to work with is the rhombus and a kite. So with a rhombus and kite, we're going to see some similarities here. When we have our diagonals, we draw a diagonal of a rhombus here and here. Those are diagonal 1 and diagonal 2. Same thing with the kite. So we can do diagonal 1, diagonal 2 like that. Area in both of these cases is 1/2 of diagonal 1 times diagonal 2. Okay, so we're just looking at those there. Diagonals in both of these cases are perpendicular. That's important because sometimes we're going to do stuff with a like right triangle. Like that's a right triangle right there. Same thing with my kite, because these are perpendicular. I can get a right triangle right here, but also right here. That's another right triangle as well. Since a square is a rhombus, this formula technically does work for a square as well. Okay, so that's something to be aware of in case I give you information that's not quite like just side lengths there. So find the area of our rhombuses and kites. So in this case, we have 8 is right here. So diagonal 1, it can be 16. And if this is 11, that means diagonal 2 is 22. So that means my formula for that is going to be 1/2 of 16 times 22. So I do 1/2 of 16 times 22 like that. And that comes out to 176 square centimeters. This kite. So again, some incomplete information here. I have 10 here. I have 3 here. Another important part about with our kites is that actually one of these diagonals will be bisected, but only one is bisected with a kite. So I know that this length is going to be 3 here. That makes this a total of 6. As far as the other diagonal goes, this part is 10, and this is not going to be 10. But I do have perpendicular diagonals. So that means I have a right triangle here. Same thing as before, I'm going to do Pythagorean theorem to find that missing piece, which is this length. And because it's a 3 and a 5, then I already know off the bat this is going to be a length of 4. So that means the diagonal here is a 4 plus 10, giving me 14 for my second diagonal. Okay, so now that I have that, I can do area is equal to 1/2 of 6 times 14. And that's going to turn into 42, and it's just going to be square units in this case. All right. So that's the basics of our formulas. Make sure that you are understanding where, like which formula you use, but also you're using the entire length of the diagonal here. So we got 6 across here and 14 up and down. So I think that's one of the biggest mistakes people will make. They just use a part of the diagonal instead of the entire diagonal. Okay. One thing I do want to cover real quick, just talking about this one, find the area of the rhombus with these vertices. So because of this, we're going to do a little bit extra of this one. It's kind of like a little challenge problem. So we're going to first plot all my points. So I've got 2, 4, 2, 4. Here's point M. N is at 5, 6. So 1, 2, 3, 4, 5. Whoops. 1, 2, 3, 4, 5. 4, 5, 6 here. 8, 4. So we got 1, 2, 3, 4, 5, 6, 7, 8. That's going to be P, and then Q is at 5, 2. So here's my rhombus. Now remember, with a rhombus, we are looking for diagonals. That's going to be the easiest way to do this problem. My diagonals are going to be drawn here and here. So I just need to count out those two lengths. So I've got 1, 2, 3, 4. So that's a length of 4. And I've got 1, 2, 3, 4, 5, 6. 6 there. So that means I have everything I need now, which is going to be 1/2 of 4 times 6. So the area is going to come out to 12 units squared. Okay. And that's it for today. So again, we're just finding our areas. We're using rhombus and kite, which is the same formula. It's just dealing with diagonals. And then we have trapezoids, which is 1/2 of base 1 times base 1 plus base 2 times the height, which is height is the distance between the two bases. All right. That's it for today. Take care, everyone.